Right, so here's my project folder with the two main recording files, side 1 and side 2 of the tape, which I've previously digitised. And I'm working on side 1 at the moment. In my notes file it says I've got to 3 minutes and 7 seconds so far. So I'm going to open this up in a program called Cool Edit, which is what I'm using. I was going to use some more recent software, but I just decided that Cool Edit, I was used to it and I knew what I was doing. So let's find 307, which is around about here, zoom in on it. There we are. So what we've got here, we've finished the section where there's the new world being built.
I know. Let's start a new sequence of names. Let's call him Quack.
Let's call him Quack. Right, so we've done that bit.
With this Quack doing. Right, look up your ears.
Right, so I say block up your ears, and then there's a Quack, and the Quack sound effect hasn't been normalised yet. So the block up your ears is at the normal volume.
Right, look at your ears.
And then you get to the other sound and it's a bit low. So, right, that is what I call a moderately loud effect. So if I go back to my reference file, it says moderate effects should be minus 12 dB. dB is a weird scale if you're not used to it. 0 is the maximum, and it goes down in negative. Don't ask me why, it's too complicated to explain. Right, so what I'm going to do is I'm going to zoom in on, this is the sound effect. And that's followed immediately by a very quiet voice. So I'm just going to cope with the sound effect on its own first. I'm going to just highlight that, and I'm going to copy it out to a new file so I can deal with it and it's in isolation. So we've just got that one sound. Now I'm going to analyse the statistics of that, and it comes up and tells me that the maximum RMS power, which is the gauge that I use, is about minus 20 dB. Now, if we go back to my reference, as I said, moderate effects should be minus 12 dB. So the difference is 8. So what I've got to do is amplify that by 8 decibels. So I bring up the amplification tool, and 8 decibels, up we go. You can see immediately on the screen the waves actually got louder. And if I play that, that's more like the level we need. Now, in some examples, which I'll probably record some of later, you'll see that we have to amplify a hell of a lot. We'll come on to that in a minute. And what happens then, of course, is the tape hiss gets amplified as well. And then we have to cope with that. But for now, let's just do this one. Now, what I'm going to do now, I could simply go back to the main wave and copy that straight in. But the problem with that is that there'd be at the beginning and the end, there'd be a sharp transition between the two, and you'd hear it. So what I do is I copy that wave. I've done a Control-C, which for anyone who uses Windows, you'll know that's copy. Go back to the main wave, and now I'm going to do a Control-Shift-V, which is a special paste. And instead of just pasting it over the top of what's there, it gives me options for pasting. Now what I'm going to do is say replace what's there. There are options to overlap and mix and things like that, but I'm going to give it a crossfade of actually 20 milliseconds. What that does is, at the beginning and end of what I'm pasting, it has a 20 millisecond period, that's a 50th of a second, where it just crossfades between the two. So you get one coming down in volume, the other one going up, mixes them together, and it just smooths the transition a bit more so that you don't hear the click as you go between the two. So do that, in it goes. Now what I always do at this point is I play the little bit before it and then hear it in context to make sure the volume's about right.
Right, look at your ears.
See, that sounds completely in keeping with the voice that you heard just before. So, yep, that's how you do an effect. Okay, so we've got that effect in place. Now let's deal with the very quiet speech that comes after it. I don't know if you could hear that then, but if you listen. There you are, made a Right, now what's happening there is, there you are, I made a whip. I'm getting fed up with saying that. And the other guy, I can't remember who he is, but he sounds like Eccles, says, is he alive yet? And I say, of course he isn't, I haven't breathed on him yet. And then there's a as I breathe on him, and you can see that it's just there. And it's quite loud. So I don't want to process that along with the other speech because it'll get in the way of working out how loud it should be. So I'm going to just take this piece of speech here. Actually, let's make sure we don't overlap what I did earlier. So you can there's a little, actually let me amplify this for you. you can see just here is the tail end of what I just amplified with the sound effect, and you can see where the crossfade is, the 50th of a second crossfade I mentioned, is happening about here, and it goes back down to quieter sound. So I don't want to include this bit with this next processing because that'll affect what I've done. So I've got to make sure I stick my cursor just here so that I'm going from the right place. Let's go back to the normal scale. You can see how quiet this tape is. I mean, effectively it could fill this screen if it were at maximum volume, and this isn't the worst. Sometimes the speech on the tape is down at the level of the actual hiss, and it's very hard to process. But anyway, let's do this bit now. So there's the speech. Up here is the at this end here. I'm not going to use the cursor this time because I need to maintain its position. That's the breathing on the new man that he's made. So let's highlight just the speech, and again I copy it out to a new file. Right, now let's listen to it carefully. Right, it's all very quiet. I can hear it, you may not be able to hear it very well, but it's all roughly the same volume. That's very important because if you're going to process something, it all needs to be the same volume to start with, otherwise different parts will be affected differently. So what I'm going to do here is say, analyse the statistics again. The maximum RMS power is minus 27 dB, that's very quiet. It's not as quiet as some of them, as I said earlier, but my reference file says that moderate speech, my commentary etc. should be minus 10. So there's a difference of minus 17 there. So I'm going to have to amplify this 17 decibels. Now let's see what happens. So amplify, 17. Right, it's nice and loud now, but let's have a listen. Right, the Eccles voice there is a bit quiet, but it's just loud enough to hear, so I'm going to avoid treating that differently because you'll hear the transition and it can get a bit ugly. So I'm going to leave him as he is. You can hear what he's saying. The only thing with this, of course, is, as you can hear, some hiss. Right, now what I'm going to use here is a noise reduction tool where I first say to it, here's a sample of some hiss. Right, you can play that and you hear a hiss. And I say, right, take that sample and say, that's what hiss sounds like. And it analyses it and it remembers it. Then I take the entire waveform and I say, subtract what I just gave you from what's there. So it takes the hiss away. Off we go. It takes a little while to do this. Right, and now if I play this back, pretty much the same sound, although it does get slightly affected by the process, but the hiss has gone. So although the sound, as I say, can be slightly coloured by doing this, it's worth it usually to lose the hiss. There are some instances where I've not bothered and I've kept the hiss because it would have affected the speech too much. You have to make a decision on each instance. Right, and again I'm going to copy this and go back to the main waveform, paste it in with the 20 millisecond overlap. Here we go. And as usual, I'm going to play that in context. So let's go back from where we started at the beginning of this.
Look at your ears.
There we are. And that, my friends, is how it's done. And you can see that what we've actually done there is we've processed, well, we're at 317, we started at 307, so I've just processed 10 seconds worth of sound, and you saw what was involved, and some of them are actually harder than that and take a lot longer.